Hi, this is Lakshmikant Tiwari. Welcome back to your new lesson. In this lesson, I am going to show you how you can use matplotlib in your Python programming and machine learning. Matplot is the most popular plotting library in Python. Using matplotlib, you can create a pretty much any type of plot. However, as your plots get more complex, the learning curve, of course, get steeper. The goal of this video series is to make you understand how you can plot with the matplotlib and how you can change the aesthetics of a figure, and then finally I'll leave you pretty much comfortable working with the matplotlib. So the first thing you need to get Anaconda. If you don't have Anaconda in your computer, download it from here, and I'm using a Python 3.7 version of Anaconda. Once you have installed the Anaconda, you will get a Jupyter notebook installed with the Anaconda along with the NumPy, matplotlib, pandas, and so many other Python libraries installed in your computer. With the Anaconda prompt, you can go to your working directory. Here my working directory is matplotlib crash course. Then accordingly you can make your working directory, and finally you can type there the Jupyter notebook. Like here I have typed here the Jupyter notebook, and once you type a Jupyter notebook, it will finally open a server here, open a server on your local computer, and then it will open a kernel in your preferred browser. So my preferred browser is Google Chrome, so it has opened a local server at a port number 8892. I do not have any file yet created in this directory, so let's create a file here, Python 3, and I'm going to rename it as a matplotlib. Okay, so just give it a small matplotlib. It looks stunning. Matplotlib crash course, right? Perfect. And before that, I have taken a crash course for pandas and NumPy. If you haven't watched those tutorials, you can go ahead to my channel, youtube.com/kgptalkie. There you will get a NumPy crash course part 2, crash course part 1, and then pandas crash course. So these are the 1 hour and the 90 minutes long crash course. There I have taught so many techniques how you can utilize the efficiency and the power of pandas as well as the NumPy. Right, so let's start with the matplotlib. Before starting a matplotlib, the few things which I would like to tell you that the matplotlib is known as a grandfather library of data visualization, along with the Seaborn and the Plotly as well as the Cufflinks. It was created by the John Hunter, and he created it to try to replicate the MATLAB. If you already know the MATLAB, you see there the MATLAB is the matrix laboratory, and the MATLAB is very famous while working with the DSP signals and simulations, etc. And there are so many things which we are going to do in this video series, like a basic line plot, scatter plot, bar plot, hex plot, and then we will be setting the axis, text, positions, labels, legends, and then finally we will be customizing the plots and the subplot and the subplots, etc. So let's start our tutorial here. The first of all, we need to do import our MATLAB. We need to import our matplotlib pyplot as a PLT. To do that, we need to write here the import matplotlib.pyplot as PLT, and after that, once it is imported as a PLT, then after that we need to do a matplotlib as an inline. This line will be used only for the Jupyter notebook. Okay, you see here the matplotlib as inline. What it does, whenever we will write there the plt.plot or something, then it will automatically show the plot on the Jupyter notebook itself. Otherwise we need to do something plt.show. Right, perfect. Now let's go ahead and try with the example there. And one more thing I would like to tell you, that you need to watch here the NumPy and the pandas. So here I'll be utilizing here NumPy library as well to generate a random numbers. To do that, I need to import NumPy as NP. Okay, so here I have a NumPy as NP, and then finally what I can do, I can create a x-axis as a linear axis, as a linear space of using linear space of NumPy. And if you see here, shift and double tap, you will see here it has a number start, stop, and the total number of the numbers which we want. So we are going to start from a 0, and then we are going to go till 10, and then finally we are going to generate a 20 numbers here, right? And let's print x. You see here there are total 20 numbers which will be represented from 0 to 10. Perfect. Now these are the 20 numbers. Now let's go ahead and generate a random number, and to do that we need to also import randint from a NumPy array. So we can say here from np dot random, okay, import randint. From NumPy, perfect. Now we have from NumPy dot random, we have got here randint. So let's create our y-axis. So that y-axis we will get here y is equal to randint, and if you place your cursor between the parentheses and press a shift and the tab, you will get here a full documentation of a randint. It takes so many parameters like low, high, and then the size. So here we are going to give first random integer 0, minimum value is the 0 for a plotting. Don't get 0, let's get it to 1, and in between the 50, and then there are total 20 samples which we are going to generate. Now here we have our y. So y is randomly generated in between 1 to 50, and these are the numbers total. The size of the array we can get by typing y dot size. So this is the 20. Perfect. Now let's go ahead. Before that, let's insert so many cell here in a Jupyter notebook. You need to press B on your keyboard, then it will insert so many rows below your working row. Right, now let's come back here and let's start plotting it. Okay, so we have already imported our matplotlib pyplot as a PLT, right? You see here this PLT. So the PLT is inside the matplotlib pyplot.py. And if you want to see here what are the other functions on which we can apply on the PLT, you need to write here dir. So the type here dir and the PLT, you will get these things which we can apply on PLT. So if you come back here, you will see here these are the plots which we will be applying there later in this tutorial, like bar plot, bar BS, bar H, and etc., box plot and the box plot, etc. Then we have so many other things here, and first we are going to do here plot, a normal plot here, right? So this is the plot. So let's do it with the plt dot plot, right? And press here shift and the tab. Now you will see there a detailed documentation of the PLT. So it takes the argument, okay, and that argument is the x and the y. X is x-axis, which is optional, and there is y-axis. Of course we need some data to plot, that is just a y-axis, okay. And then we have coordinates of the pointer, line nodes, etc., and etc. And then finally we can also set so many other things like labels of the x-axis, y-axis, the marker size, styles, etc. So here are so many other things, right? Perfect. So this is the detailed documentation. Now let's go ahead, type here plt.plot, and we are going to give here input y-axis input, that is the plt.plot y, shift and the enter. You see here, this is our plot. Okay, and if we do sort this y, then what we can do here, y dot sort, right? Let's print it. Sorry, we need to do here sort and y. Sorry, this should be the np.sort, right? So we have got here the np.sort is equivalent to like this. So let's do one more thing, y is equal to np.sort and then y. Perfect. Now let's again plot this, plt.plot, and now you see here we have got our plot something like this. Well, very well. Now here you see here the x-axis is random. I mean, we don't have any control on the x-axis. To have a control on the x-axis, what we need to do, we need to also pass a x-axis array, which we can do with the plt.plot and x and y here, right? If we plot this, you see here now we have got x-axis. Now we have a control over x-axis. So if we change here x, then this axis will be also changed. So let's change this x from 1 to 10. Okay, and now you see here this starts from the 0. This starts from the 0 and ends at the 10. And if we again press here the shift and the enter, you will see here it starts from 1. Okay, so the data starts from the 1 and ends at the 10. So this is how we can control also the x-axis. So let's go ahead and change the color of this line. By default color is blue. We can change the color with the another arguments in which we need to pass here color. Okay, that is R represented for a red here and B represented for a blue. How we know this? You can press here shift and the tab, and if you see here this detailed documentation, you will get here B for blue, G for green, R for red, C for cyan, and all those things, right? And there are other so many the marker characters, like if we put dot, this will be a point marker, this will be a pixel marker, this will be a circle marker, this will be a triangular down marker, and there are so many other type of the marker. And then there we have a line styles and right, perfect. So we have a line styles, we have a markers, we have also color, and here we have a marker face color, marker face color alteration, marker alternate face color, marker size, marker every. There are so many parameters which we will be learning throughout this series. Now we have here our blue color, so let's make it green as of now. So now we have here green color. Another way to set it with the color, okay, we can say here a color, sorry. Another way to set it here, we can say here a color, sorry, oops, sorry, we can say here a color is equal to red, perhaps something is wrong there, I'll show you that later. I think is it color, yes, it is color. Okay, now the color equal to the red here, we can also pass a green or any color whatever we want. Apart from this, you can see here we do not have any labels on our y-axis and the x-axis, and neither we have any title into our plot. So let's give here x-axis and the y-axis, which we can do plt with the x label, plt with x label, and then we can say here this is our x-axis. Okay, and let's plot it. You see here we have x-axis, and if we try to set our the y-axis in another cell, it will not show y-axis or x-axis. Let me show you how. If I say to you that plt dot y label, okay, if I say here y value, you see here it will plot a new figure on a new canvas and it will set a y value on that new figure. So that's mean if you want to, plot this y-axis on the same plot, then I need to write this line of code in a single cell. So what we can do, we can cut it here and then we can write it here with y label, okay, is equal to y. Now you see here we have x-axis and y-axis, and similarly we can set a title like a plt.title, and if you press a tab there you will see here a suggestion. So we have here a title and then we can say here a random plot. Okay, perfect. Now you see here there we are also getting an output since this plt.title returns something. To remove this, what we can do, we can write here the plt.show. Right, now we don't have that outputs here. Very nice. Now we have our plot here, a first plot. Now let me ask you a question. Let's say if you want to plot the two plots side by side or one after another, how would you do that? So let's see how we can create a multiple plot on the same canvas. So do you understand what is the mean of the canvas? Let's say if I say to you that plt.show, the plt.show, is it the plt.plot? Yes. So this is the plt.plot. So this have a same canvas, this have one canvas, as well as by default this has a single axis. So these are the axis and this is a full canvas and this is our current figure. Okay, so let me give you an example, then perhaps you would understand it in better way. To do that, what I can do, I can write here the plt.subplot, and then I'm going to define here the number of rows, how many rows I want. I want only one row, but the two column of the plot, and I'm going to refer here a first of that. Okay, that means if I say here 1 2, that's mean there would be one row and the two plot in another column. That's when there will be one plot and there will be another plot. And by defining this one, I am referring that I am going to select here this plot. And if I type here the 2, that means I am going to refer here the second plot. Let's see what does it mean. So this is the one plot, and if I say here similarly the plt dot subplot 1 cross 2 cross 1, then see we have here the two plots. So let's make it better in a better way. Now here we have a 2. So now here we have 1 and the 2, right? So here we have a 2 subplot. Perfect, you got it. Now let's go ahead and plot some data on these on these subplots. So now you see here this is a full canvas. You see the things which I am moving, that is the full canvas and a figure, and these are the axes. Okay, so these are the axes. So this is axis 1 and this is the axis 0, sorry, axis 2. Okay, so let's go ahead and plot some data there. There we can do here the plt dot plot, plt dot plot, and we are going to plot here x and the y together, and then I am going to plot it into the red color. Okay, and similarly what I am going to do here after that, I'm going to plot here the plt dot plot the x-axis with the y-axis, and the color is going to be the blue. Okay, so let's plot it. You see here now we have a 2 plot here. Now let's go ahead and create a y2, that is the y square. So that is the y square here. Okay, y2 is y square. Now I'm going to plot here y square. y2 and y square is a little bit different. Let me change it in another way. What I can do, I can multiply y and x together to create it in better way, right? You see here now we have y and x together, right? Perfect. Now what we can do here, So we have y2 and this one. One more thing, now this is the line, right? So with the plot, this is the line. But you see here, if you type here shift and the tab, you see there is a marker. What is the mean of marker? That's mean this one. Okay. In general, this has a three option. The first one is the color, and then the marker, and then the line type. Okay, you see here. So this has the G for color and O for marker, and there is a line type. Okay, so let's replace it with the GORROO. Okay, so here we have red color and O is a marker and double dash is a line. Okay, if I give here a single dash, then that will be a dashed line. You see here, right? And if I delete that as well, then you will see here this has become a scatter plot. And similarly, if I say here a star and then a dash, you will see here, now this is a star will be at every data points, and those data points will be connected with this dash. If I remove this dash, it will be just a star. Okay, so this is how we represent these color options and line types and their size, etc. Right, now we can also change the marker size, which we can do with the marker size. Okay, so let's say here the marker size is equal to 16. Now you see the marker size is 16 here. We can set marker size the 10. Now it is the 10, and we can also set a marker size to the 5. You see now it is a 5. Perfect. Now go ahead and I'll tell you some difference between the MATLAB and the matplotlib. Okay, so what is the difference between MATLAB versus matplotlib? Okay, so MATLAB is kind of a very systematic language, and but here we are talking about a matplotlib. So the matplotlib can work as a MATLAB language, as well as it can work like object-oriented language. Okay, so the object-oriented methods. Okay, so this is the matplotlib, object-oriented. The main idea in using it into more formal object-oriented method is to create figure objects and then just call methods or attributes of that object. That means, let's say here I have shown these images in kind of the MATLAB way, but I'm going to show you some figures in a object-oriented way. So object-oriented way, plotting a figure into object-oriented way give you more control to control aesthetics of those figures, and you can make that looks really nice. So what is the object-oriented way to do matplotlib programming? So that means we are going to create an object of a figure, an axis, then we are going to provide a methods on those objects of a figure and axis. So let's create a first object of a figure. We can do at fig is equal to plt.figure, right? So it will take by default figure there, and if you type there the tab option, shift and the tab, you will see detailed documentation of a figure. It takes a figure size, it takes a DPI, it takes a face color, edge color, and so many other things. Okay, so I have just created an object of a figure type, you see there, with the axis 0. Okay, and then I am going to add an axis in that figure. Okay, so that is the axis is equal to fig dot add axis. Okay, and that is the x-axis which we are going to add there. So the first we are going to add here the 0.1 and then the 0.1, and then we are going to set it to the 1 and the 1. What does it mean? That I mean a figure which will be plotted there, it will start from 0.1 location, that is the top, bottom left and the bottom, 0.1 and the 0.1, sorry, the 0.1 of the x and the 0.1 of the y, and then it will go till the 1 and the 1. Okay, so there would be something like this. If I run this, we will get a empty plot, axis plot like this. Okay, so this can be treated as 0.1 location, right? And then this can be treated as 1 location. Even though if you change it something like the 0.5, you might not notice any changes, but definitely you will notice a change when we will be plotting two plots together. That means, let's say if I plot a single plot from 0.1 to 0.1, that will start from here, and let's say if I plot another plot, suppose that from 0.5 to 0.5, that will start from here. So the plot inside the plot, I'll take that later. I'll show you how you can plot a multiple plots. Let's get back to this plot. So we have two objects of a figure and the axis. So let's apply methods on these objects. So the first, I'm going to apply a plot object, the plot method on the axis object. So that I can do with the axis dot plot. Sorry, that dot plot. Now we have axis dot plot. There I have x and y, and then finally I have a red color there. Let's say if I plot here, you will see this one like this. Okay. Now if I do the plt, sorry, the plt dot x level, you see here it is still working, right? But that means we can mix this object oriented as well as the MATLAB way to plot a signal, but this is always recommended that you should follow a single type of the convention. Now let's add x label in an object oriented way. So we can do with axis dot set underscore x label. One thing you might have noticed that in the PLT way we had a PLT dot x label, but here we have a set x label. Okay, so you need to replace every methods with the set underscore. Okay, so here we have x label, that is the x, and similarly we will have axis dot set underscore y label, that would be the y, and similarly we would have axis dot set underscore title, and that is the set title of random. You see here we have everything, x label, y label, and the title. So this is the object oriented way of the programming. In this way we will be having very much control, right? So let's say what are the methods which is available for the axis object. We can check those methods with the dir access. So these are the methods which is available to apply on the axis. You see here there are so much. Okay, angle, annotations, arrow, artist, auto scales, fill. There are so much things which we can apply. Okay, perfect. You see here on the set we have a set figures, set frame on, set frame off. Okay, and similarly we have set grid, set in layout, set level, navigate, etc., picker, position. There are so many things which we can set. Even we can set a limit of the x-axis and the y-axis. We can set the x ticks labels, x ticks, and y limits, y bounds. There are so many things which we can do. Let's go ahead and learn all those things which we can do. Although one thing I should accept that the coding is a little bit complicated, but the advantage is that we now have a full control of where the plot axes are placed, and we can easily add more than one axis to the figure. Okay, perfect. Now let's go ahead and I'll show you the things which I was talking earlier, that how you can add two figure in a single figure. Okay, that means let's say there is one figure and now I am going to add another figure here. Okay, so let's go ahead and see how we can add that figure. Perfect. To start that, we need to first create the figure objects. That we can do with the figure is equal to the plt dot figure, and then we have here the axis 1 is equal to fig dot add underscore axis. Okay, so here we are going to set axis for axis 1. Moreover, I'm going to put it ax1, that is the axis 1, and the axis is going to start from 0, and it is going till 1 and 1. And similarly, we are going to start the axis 2 with the figure dot add axis, and now I am going to start this axis from the 0.2 location of x and 0.5 of y. That means it will start somewhere into the middle, somewhere from here. Okay, this is the point 2 and this one, and then this is going to be till, let's say we wanted 0.4 to 0.3. okay, so the 0.4 to 0.3. sorry, this is the actually the width. Okay, so this is the width. Okay, this is the starting position and this is the width for x-axis and the y-axis which we want. Okay, you see here. Okay, perfect. Go ahead. Now if we plot it here, you will see here, there we have got here one plot here and another plot there. We can change it to the 0.1 and then we can change it to the 0.6. So let's go ahead and see. Now our new plot is here. So let's go ahead and plot our plot there, the both plots together on the axis 1 and the axis 2. To do that, what we can do, I'm going to first plot on axis 1. That we can do ax1 dot plot, and there we have x and the y, and similarly we can do on the ax2 dot plot. There I have x and y square. Okay, sorry, you see here. Now we have both plots here, and now let's change the color of these plots. The first one I'm going to put into the red, and the second one I'm going to put it into green. Okay, see here, this is how we can make the changes. Now let's go ahead and change some x level and the y level. Now we have the ax1 dot set underscore x level. There we have x, and similarly we have ax1 dot set underscore y label. There we have y, and similarly we have ax1 dot set underscore title. There we have this is the larger one. Okay, I can say here this is y plot. Okay, and similarly I can copy it and then I can paste it here, and then finally I can say this is the y2 plot, and then I need to of course change it to ax2. Let's go ahead and see here, this is y2 plot, that is y square, and this is y plot. So this is the how we can get a full control of a figure and a plot by using object oriented way or techniques of matplotlib programming. Okay, so till now we have talked about the subplot. You know what is the difference between the subplot and the subplots? Sorry, let me tell you it into a little bit more detailed way. So till now we have talked about the plt dot subplot. Now we are going to talk about plt dot subplots. Okay, so this is the good time to talk about the plt dot subplots. Earlier we had talked about the plt dot the subplot. You see here we have plotted the two plot. You know what is the difference there? The plt dot subplot is a kind of the MATLAB way. This is not the object oriented way to program to the plot a figure. So this doesn't give full control to each figures or each axis, right? So let's say if you want to plot a 10 figure, then we need to write here the 10 10 times of this code. Okay, the plt.subplot 1 2 3 4 dot like that. So that's the very hectic actually. But if we do in a plt.subplots way, then it will be into object oriented way like this one. Then the plt.subplots returns figure and the axis. Then in that way we can control our figure aesthetics, and we can also control the data in each plots. Okay, so let's go ahead and try to understand what I'm talking about here. So we have a figure, and then we have here the axis is equal to the plt dot subplots. Okay, so here we have one subplot by default here. Okay, and I'm going to pass here at the 2 subplot. That's mean I can do 1 comma 2. That's mean there would be 2 subplots. Okay, and if you see here the axis ax, this is the array. So this has the 2 axes, the axis 0 and the axis 2. So axis 0 and axis 1. And if you see here the figure has only the canvas, a real canvas, which has the figure axis 1 and the axis 2. Okay, now let's go ahead and do some coding on the ax0. That's mean we can also get ax0, as well as we also can get ax1. Okay, perfect. Let's go ahead, and the first thing which we are going to do here, we are going to do a for loop. Okay, so actually there are 2 ways. The first, I'm going to do it into the brute force way, and then I'll be applying a for loop. So here we have ax0. On the ax0 I'm going to do a plot, ax0 plot x and y, and then we have here a b. Okay, perfect. Let's plot this. You see here now we have this one like this, and similarly I'm going to do for ax1, and then that will be ax1 dot plot. There I'm also going to pass x and y, but into a red color. Okay, so now we have here the 2 figures. Let's so this is the brute force way, but we can do also in like a for loop as well. So for that we need to again create a figure and ax, right? Figure and the ax is equal to the plt dot subplot, and now we have 1 and 2, and then I can apply here a for loop for let's say ax, okay, for axis in ax, and then we have axis dot plot, then we have x and y, right? So let's run this for loop and we will see here. This says that illegal argument to subplot. Oh, sorry, this should be the subplots. You see here now we have got the both plot. Now we can change the color of this. Okay, the color very easily. There are so many things which we can do there. So let's change the color into a G, with the G that is the green. So this is the both color. Okay, so in this way we are changing the both color, but there are other things which we can do. So let's create a list here with the color. We have first here a red, and then we have a green. Okay, so here we have color like this. Now we are going to get here axis y for enumerate. Okay, so let's enumerate this ax, and then what I am going to pass here, I am going to pass here color and then I. Okay, you see here, so this is the first one is the red, and second one has become a green. And the similar way we can create data, the list of the data. The first one is y, another one is y2. Okay, and now I am going to pass here the data and then I. you see here now we have two different data. So x-axis is same for both the figures, but you see here the data. For a first one I have passed a y, and for second one this is just a square, a y2, right? That is the x and actually the y, multiplication of x and y. Okay, perfect. And another thing which I would like to tell you that, so if I write here a figure, right, the figure dot tight plot, okay, the fig dot tight layout, actually this is layout. So the fig dot tight layout automatically adjusts the figures, the x-axis and labels, titles, etc. automatically. So it basically the fig dot tight layout avoids any overlap of text and other things. Okay, perfect. Now let's go ahead and try to understand. Let's say if I would like to change the figure size, then how we can change this figure size. Now let's go ahead and see how we can change the figure size, aspect ratio, and it's a DPI. Okay, so here we get default figure size in our Jupyter notebook, but now I'm going to show you how we can change a figure size and it's a ratio. Okay, so let's go ahead and type here. What we can do, we can copy this impact, right? Or otherwise let me draw a new figure, okay, from a scratch. So here we get a figure is equal to the plt dot figure, and if we press shift and the tab we will get a lots of option. So there is a figure size. Okay, so we will get this figure size there, and that's we are going to put here 10 by 6. So that is the figure size. Okay, and if you again see here, there is DPI dot per inch, and initially I'm going to set here 100. Okay, so that's the DPI is equal to 100. Right, once we have this one, then we are going to plot it. Okay, so this is the figure, and as you know, the plt dot figure returns, our plt dot subplots returns the two variable. One is the figure, another one is axis. Okay, so here we have figure and axis. Sorry, we have here figure and the axis. It says that this cannot unpack non-iterable figure object. Oh, sorry, this is a plt dot subplots. Okay, so we have axis and the plt dot subplots. It's quite large, so what we can do, we can decrease it a little and then we can make it 4. Okay, now we have an axis and a figure object, so let's go ahead and type here axis dot plot, sorry, axis dot plot. Then we have here x, y, and then red color. Right, perfect. Now let's go ahead and give it x, y, and the title. Then ax dot set underscore x label, that is x, and ax dot set underscore y label, that is y, and then ax underscore set, and then title. The title we are going to say here random number plot. Okay, perfect, we have got it. Sorry, ax dot set title. So random number plot we have got with the x-axis and y-axis. So let's go ahead and save this figure. Right, so now we can change the aspect ratio and the size of the figure with this one itself. Let's say if I say it 12 and the 4, you see here aspect ratio has been changed. Now one more thing, let's say if you want to use your figure somewhere else, then how you can save your figure. To save this figure, you need to right click and save this image. Otherwise, if you want automatic save of this figure, then definitely there is another way in which you can save this figure. To save this figure, you can call a figure object, a fig, dot save fig. Okay, so there is a save fig, and if you press here shift and the double tap, a save fig documentation will expand here. Then it asks you first a file name, and then if you want to another DPI, that means if you want to change the DPI in which you want this image to be stored, and then even if you want, you can change the face color and the edge color and other things like orientations, the property and the format and the padding, right, etc. So the by default the padding is only the 0.1. okay, that's mean this whole image, this whole figure will be stored or saved, and there would be just a small padding around the figure. Now we can give a name, a file name. So here I'm going to give a random file .png. We can also save it into the .jpeg as well, and then I am going to put here DPI is equal to 300 and just hit the enter. You see here now we have a random fig.png and we have a very large DPI. That's why image is quite high. Okay, so let's get back to the 100, and if we see it now, then this image size has been reduced by 3 times. Okay, perfect. So this is how we can save an image. Now let's go ahead and play around with the legends, labels and the titles a little bit more. Earlier we have seen how we can set it with the ax dot set underscore x label, y label, etc. Let's say in some way if you want to add a legend, then how you can add a legend, right? A legend, that's mean a number to this line, a recognition to this line. How would you recognize this line? To set the legend, what we can do here, we can just simply call a legend. Okay, so x dot legend. Okay, so in this way we can call a legend. You see there is a legend, very small legend, but it doesn't found any label. Then how we can get a label? To get a label, what we can do, we can call it here a label, and label is first one is y. Okay, and if we hit the enter, we get an error, and we get error because we have put label at the wrong place. We don't need to put it there. We need to put a label here. That label is y and multiplied by x, if you remember. Okay, so here we get here a label with multiplied by y and x. Even though we can set a location of the legend there, you need to press here shift and the tab. You see there is some arguments which we can pass there. Let me show you. You see here the location, the best locations, upper right, upper left, and there are so many other locations. Okay, and there are so many other the arguments which we can pass to legends. Okay, there are so many, although as of now we do not need those arguments. So this is the way how we can plot a single the data on a plot, but we can also plot a multiple data on a single plot. We can do like this, ax dot plot, and then we can pass y and y2, and then finally we can plot it into the blue light, the blue color, and then finally we can call our label is equal to this is y and this is y multiplied by x. You see here we have got y and multiplied by x, and we have also got a y, right? Perfect. So this is the way how we can work. Even though we can also multiply this y, or we can do a square of y. So this is the way how we get this, right? y2, that was the y2 actually. Okay, so now let's go ahead and learn a little bit more about the legends, and let's see how it changes with the location. So we can do a loc is equal to the 0, that is the default position. If we say it 1, it will change back to this place. If we give 2, it will get back to here. If we pass 3, that is here, and if we pass here 4 or the 5, then it come back here. So in this way it goes. Okay, and with the 0, that is the best location, and the best location is this one. Okay, so this is the way how we can set legends, X labels, Y labels, and the titles. Now let's go ahead and see how we can set a color, line width, and the line types. Okay, now let's go ahead and very quickly create a subplot here. Fig and the AX, the PLT dot the subplots. We have a single subplot here, and then I'm going to put here AX dot plot, and then I'm going to put here X and the Y, and then I'm going to plot this into a B, that's the blue, and then there is the dot. Okay, and like this way. Let's see what will happen. So this is the way how it happens. And sorry, if I put here a double dash, that is the dotted line, and if I press here underscore, so it goes like this one, and if I press here star, so in this way, if I write it here a colon, that this goes in this way. So there are so many things in which we can do. We can press here shift and the tab. We can go ahead and see all the way in which we can change the line type. Okay, perfect. And there are a few other arguments which we can pass there. The line styles, so these styles, we have these styles, and we have these styles. Here is another styles, and there is a blank styles. Okay, so that is the line styles. Perfect. And then we have also a marker, and these are the way in which we can mark it. So these are the marker which we can use actually. Let's say if I put it here 1, so this is the way how we can use this. Okay, if I put it 2, so this is the way how we can use this, right? So this is the how we can change the line color as well as the marker color. And to change the marker size, we can put here the marker underscore size, sorry, the marker and size, and let's make it the 12. In this way we can change the marker size, right? Perfect. And if you want to change line width, so in this way you can change the line width. Okay, so we can make it also the 3. The line width is, you know, now this is quite thicky, right? Perfect. Now we can also change color in another way. Let's say if we don't want to change a line and we want to keep it as a line, just a line, then in that way what we can do, we can also pass a color with a color, and then we can pass here a coded color as well. Otherwise we can also pass here a hex color. So let's give some random number to our color, and we see this something like this. Okay, so this is the way how we can change a color, right? Our subplot. Now let's go ahead and look more about how we can get a plot range, right? How we can get a plot range. To do that, a plot range, I mean, let's go ahead and explore a little bit more about the subplots. And to do that, let's go ahead and create a subplot very quickly. We have here a figure and AX, which says that the PLT and PLT dot subplot, sorry, PLT dot subplots, and then it is asking about the 1 row and the 3 column, and then I'm also going to pass here figure size, that's the fig size, and that fig size is here 12 by 4, right? If you see here, sorry, somewhere this says that invalid syntax. Let me see why this says that invalid syntax. Okay, perfect. Now we have got a 3 figure and 3 axes in one figure, axis 0, 1 and the 2. Now let's go ahead and change those axis plot. We can do with the AX0, and then we can do the plot. Then we have X and Y, right? In this way we can get plot data here, and in the same way we can also get two plots simultaneously in a single axis, like this way. Okay, so here we get a two plot in a single axis. So earlier I have shown you this way, in which you can get with the two different, by calling two different plots together, and this is the another way in which you can get two data plots in a single axis. Okay, perfect. Now let's go ahead and plot AX and the 0, sorry, AX1, and in this way I am going to plot here X and Y square. Let's plot it with the orange color. Let's plot it with the orange. Sorry, we don't have any orange color. Okay, we have a black color. Sorry, we have a black color. Now this is plotted with the black color, and but if you see here, the limit has been changed drastically. Okay, so there are another way in which we can control x-axis and the y-axis. So let's say if we want to control x and the y-axis, how we can do this? We can simply write AX1, and then we can call set underscore y lim. Okay, and now we are going to set y limit from 0 to just 500. Okay, so in this way we will get our y limit in between just 0 to 500 for AX1. That's mean for axis this one. Let's say if you want to zoom in this plot, then how you can do that? We can do that like this: AX2 dot plot x, y, and then x, and then y2, and then finally we can set here a y limit. Then we can call set y lim. If you are wondering how we can how I remember these things, I mean which methods can be applied on this axis, then simply what you can do, you can call a dir and then ax. Okay, so once we call dir and the ax, you will get everything which we can apply on this one. Right, now let's go ahead. I think earlier I had also shown somewhere which we can apply there. Do we have somewhere? This is for PLT. I think in between here. Yeah, we have here, right? Yes, so we have here which you can apply set x lim and the set y lim, set y label, y bound. There are so many things which you can do. Okay, and if you want to know more like that one, then you can call here the dir and then ax0. So these are the things which you can perform on axis 0. Okay, perfect. Now let's go ahead and set y limit. If you press shift and the tab, you should get actually detailed documentation of set underscore y limit. Here I am going to pass 0 to 500. Or 0 to 100, let's say, and I'm also going to set limit for my x-axis as well. Then I would call set underscore x and the lim, and I'm going to pass here string list. In that way I'm going to pass that limit in between 1 to 4. Okay, just plot it. Now you will see here we have a zoomed version of a plot 1. Okay, perfect. Now go ahead and see what are the some other kind of the plot which we can utilize. Okay, so let's again go ahead in dir and type here plt. There we have so many other types of the plot, like the plt.plot, which was like a normal line plot, but we also have some other kind of the plot, like a bar plot. We have a bar horizontal plot. We have let me show you some other type of the plot. we have some other plot, histogram. Yes, we have a histogram plot, and so many other type of the plot. Okay, so let's go ahead and see what are the other type of the plot which we are looking. Okay, so there I'm going to first call a scatter plot. Okay, the plt.scatter with x and the y. Okay, so this is a scatter plot. There are many specialized plots we can create, such as the bar plot, histogram, scatter plot, and much more. Most of these type of the plots we will actually create using a Seaborn, which I'll be taking into the next series, next video tutorial. And we can do almost everything what this matplotlib do. We can do almost everything into the Seaborn, but the greatness of the Seaborn is that there are most of the things which Seaborn automatically handles, like the aesthetics of a plot and controlling the data axis and color, etc. Okay, so we'll take that into the next tutorial. Let's go ahead with the matplotlib in this tutorial. Now we have seen a scatter plot. Let's go ahead and see a bar plot. Okay, now I am going to create a sample here first. Okay, one more thing I can do here. I can call here a plt.bar plot. Do we have bar? Okay, so we have here a bar plot, and if we press here shift and the tab, we will get here, we should get x-axis, we should get x data which we will be passing, height, width, and other things. And if you go and see a detailed documentation, then definitely here is a detailed documentations. Okay, something like this. Perfect. Now let's go ahead and pass here x. plt.bar, and we should also pass here height is equal to, let's say, 1. Right, so that is just a single data. Okay, oh sorry, there are so many data in between 0 to 1, and then we can also pass here the width. Let's pass it 0.5. the width has been reduced there. We can also pass here y. So this is the y-axis. Okay, and the y is kind of the y will go along the x-axis, and it will plot that how many number times it has occurred. Okay, so let's go ahead and create a sample for proper bar plot, and then I'll show you what I'm talking about. So from the random import sample, and go ahead and create data with the sample, and then I'm calling the range here. Range I'm going to get from range 1 to 10,000. Okay, and if you see here, the first one is the population, and then k says that how many unique random elements from population sequence are a set. I'm going to pass here a 10. Okay, and if we get here the data, so we have 1 2 3 4 5 6 7 8 and 9 and 10 total. Okay, now let's go ahead and plot this. Perfect. And let's go ahead and plot it with the histogram. Okay, then I'll show you what I'm talking about. Plot it with the histogram, pass here data, then you will see here we have a histogram. Okay, which has these numbers, right? There how many number of times these has occurred. Okay, so this number, which is around, I think 114, was occurred the 2 times, and there this number and this number and that numbers. Okay, this is the way how it can work, and we can also control the width there. Perhaps, do we have width? We have weight, we have a density, we have a range, color, align, and other things. Okay, we have R width. So let's see if we can control with R width. sorry, 0.8. There we have a R width. Okay, so in this way we can control the width. So this is the how we can plot a histogram. Let's go ahead and see how we can plot a box plot. Now once again, for plotting a box plot, I am going to generate the data. Okay, so in the form of the random numbers, and that random numbers which I'm going to generate, I can generate with the np dot random and then dot normal. I'm going to create with 0, and that's the with the std you see here. Okay, so std will say that the standard deviation, and that's the 100. Another one is 100. You see here, sorry, it says that the std is not defined, so that means I need to define here standard deviation. Standard deviation is 3.3. There is 100 data has been generated, and then I am going to create a for loop here. Sorry, standard deviation actually, sorry, the std, and then for I'm going to get a standard deviation from this for loop, which is into a range of 1 to 10. Okay, sorry, this says that somewhere this is invalid syntax. This says that this is an invalid syntax. I'm going to create this into list. Perfect. Now let's go ahead and place it into the data. Now we have a data. Now I am going to plot it. Okay, so the plt dot box plot. Okay, now we have a box plot with the data, and then we have BERT is equal to the true. What is the BERT? You see here, you will get everything here. The BERT is if it is the true, makes the box vertical, that's the vertical, otherwise box are made up horizontally. Okay, perfect. So vertically is the true, and then patch artist there, that is also a true. If you are wondering that what is the patch artist, then you can go ahead and see here what is the patch artist. Right, you see here, you see patch artist. If it is false, produces boxes with the 2D. Okay, otherwise boxes are drawn with the patch artist. Right, that means to understand this, what we can do, we can first make it false. Sorry, right, so let's go ahead and make it false. Let's just plot a 3. Okay, right here now we have the plt.show. Now we have our box plot with the 3 with only the 2 box plot here. Okay, so in this way we can plot a box plot. These are the outliers, and this is the lower quartile, and this is the higher quartile, and this is the median. Okay, perfect, go ahead. Right, so this is how we can plot a box plot. We have learned how we can plot a histogram, how to bar plot, and the scatter plot. Let's go ahead and learn a little bit more about the advanced matplotlib concept. Okay, now let's go ahead and let's come back, and I'll show you how we can plot these axes on the logarithm. Right, have you ever wondered on audio scaling or the FFT, if you are doing FFT etc., or a spectrum plotting? The spectrum plots are being done on log scale. So do you know how you can do a log scale plotting of any axis, x-axis or y-axis? If you do not know, then I'm going to show you how we can do a log axis plot. Okay, so let's go ahead and very quickly create an object of a figure and axis with the plt.subplots. I'm going to plot here the 2 plot in a single row, and then I am going to set here a figure size, sorry, the figure size, and figure size is here 10 and 4. Okay, now we have got a figure size there. Let's go ahead and set axis plot here. So we have ax0 dot plot, and then x, we have here x, and then y, then another plot we have x and y2. Let's plot it, you see here. And also I'm going to do here pig. Okay, perfect. Sorry, I should not do that one. Pig dot tight underscore layout. Okay, so here we have a figure dot tight layout. Now let's go ahead and see how we can plot data on our another axis. That we can do with this one. What we can do, ax1 and then plot. Here we have x, and I'm going to plot here exponential data. That we can do np.exp, that's the exponential data with the ax, with the x. Okay, so this is the exponential data. Now my question is how we can do a log scaling for this x-axis. Okay, so see this this y-axis is currently a linear axis. Okay, my question is how we can do a log scale. Okay, to do a log scale, there are few things which we can do here, and to do that, so now let's change this y scale into a log scale. Then how we can do that? We can call here ax1, and then we can call set y scale. Sorry. Then we can call here set y scale, and in this way we can call here log. Now you will see here the y scale has been set into a log format. Okay, perfect. Now let's go ahead and as you know, if we take a log scale, then exponential of x will go just like a straight line. So that's why it is showing like a straight line. Okay, now let's go ahead. You might be wondering that what are these things? Okay, these are the ticks. So yes, this is a ticks, and we can also control the tick, its a size, its a color, I mean everything about the ticks. And now let's go ahead and see how we can set and reset the ticks, and how we can change the levels of the ticks. Okay, so let's go ahead and give a new values to these ticks, and I'm gonna give a new value to these ticks. But before that, what I'm gonna to do here, okay, let's create a new figure first, then I'll do that. Okay, so here we have a fig, and the axis ax is equal to the plt dot subplots. Okay, and then we have here a fig size. A fig size is equal to how much? Let's say we are going to do for 10 and the 5. Okay, so this is the fig size. Now we have got object of a figure and axis. Let's go ahead and plot some data on the axis. We are going to plot here, let's say the y2, and okay, perfect. And let's set lw is equal to the 2. And you might be wondering what is the LW. If you see here, you will find the LW. Okay, let me see, where is it? LW, it should be somewhere here. Okay, so I'm not able to find it as of now, and it has just slipped from my mind. In any way, we can do the same thing here like this. And now we need to set these ticks. Okay, these are the x ticks. Okay, we can do with ax dot set underscore ticks. Okay, so this is the x ticks. Okay, set x ticks, and we are going to set x ticks with new data format here. How many data formats we have here? We have a total 20, but although we are going to just set a few here. Okay, now you see here we have x tick only till 5. Okay, and the other x tick we do not have. And if you want to set empty, okay, to set it empty x tick, we can just pass here a empty list, right? Perfect. Let's go ahead and press a shift and the tab. You will see here we have here, okay, the ticks, okay, the list, and we can also pass here x, then we will get a complete, okay, the x-axis here ticks. Perfect. So this is the way how we can set a ticks, and let's set here 1, 3, 5 and the 10. Now you see here we have 1, 3, 5 and the 10. Okay, and in another way what we can do, we can also set a label to each of these ticks. Okay, so these are the ticks, and let's modify these labels. Then how we can modify these labels? Ax dot set underscore x ticks and then labels. Now we are going to set here, let's say the A, and then finally we are going to pass here a B, then finally C, and then let's say we have a D. Okay, you see here, sorry, this says that it doesn't have any attributes set x ticks label. Okay, it should have ax dot the set x ticks and then labels. Otherwise what we can do, I already have a working example. Let me copy this one here. I might have done something a little wrong there. Let's say here I have a set x ticks label, and then here I have alpha, beta, gamma, delta and the epsilon. Okay, so let's run it. You see here we have alpha, beta, gamma and then the delta, and we should also remove this epsilon. Perfect. So here we have alpha, beta, gamma and the delta. So in this way we can we can change it. Either we can pass here A, you see here we can pass here a B, right, and whatever we want. Right, so this is the way how we can change the ticks, right? And you see here the ticks are the outside, right? And let's make these ticks inside. Okay, how we can do those ticks as inside? Let me see. Okay, we should have something. I'll show you that later, how we can make a ticks, go inside. Okay, let's go ahead and change y ticks. For y ticks, what we can do, again, ax dot the set y ticks. Okay, then in that way what we can do here, sorry, set underscore y ticks, and then here I'm going to just pass here empty list. Otherwise we can pass some data here, let's say the 0 and 100 and then 500. You see here we have a 0, 100 and the 500. Even though if we pass here 1000, so it will also show that 1000, but this graph real data will be squeezed down. Okay, now let's go ahead and see it in a better way. One more thing, you might be wondering that you see here these data are not being printed into a scientific notation. So let's say if you want to print value x-axis or the y-axis, especially the y-axis values into a scientific notation, then what you can do or what we can do. To represent it into a scientific notation, there are a few things which we can do by using a formatter into a Python ticker, into a matplotlib ticker package. So let's go ahead and do that. Quickly I'm going to first create a figure and the axis object with the plt.subplots. Okay, and now I'm going to call here ax.plot, then I'm going to plot here x and the y too, right? And then finally I am going to call here a title, that's the set title. Okay, ax.set title, and then I'm going to call here a scientific notation. You see here we have got a title as a scientific notation. Perfect. Now I am going to import ticker from matplotlib. So from matplotlib, import the ticker. Okay, perfect. Let's go ahead, and here I am going to call a ticker scale formatter. So for that I can write here formatter is equal to the ticker dot scalar formatter, and the scalar formatter have some options like use math text and offset etc. So I'm going to call here use math text the true, and once we have that, then we are going to call here a formatter and then set scientific the notation to the true. Now we have a scientific notation has been set true, and now we are going to set a power limit. So let's set a power limit with the formatter. We have now a formatter dot set underscore power limits, and then we are going to set those power limits to -1 to -1. Okay, perfect. Once we have this, then we can do axis the alteration ax dot y axis, ax dot y axis dot set measure formatter, set underscore measure formatter, and then I am going to call here formatter. You see here now this limit has been set here from -1 to +1. Okay, so this is all about in this video. Please do not forget to subscribe this channel, and please do not also forget to like this video. I'll be making so many videos into a machine learning Python, and next video is gonna be on a Seaborn. Please stay tuned with this channel, and please do not forget to subscribe. Bye bye, have a nice day.